Okay, so let's do question number 8. The first requirement for this question is that we need to give our answers to part A, I, and C, I, and D correct to 2 decimal places. Okay, so it does not really follows the specific requirement for math exam, right? And also you can see that this is a financial question. That means this question is from the topic 1 of your curriculum. Okay, so here we have Daniela and Soren have each recently received some money, and Daniela won a cash prize and Soren received an inheritance. So Daniela had 2 options to choose from to receive her winnings. In both options, she receives a payment on the first day of each month for 3 years. So N is 3. So option A is each payment is $42,000. Option B is the first payment is $1,500 in each month, which follows the payment is 4% more than the previous month. So question A, we need to find the total amount Daniela would receive if she chooses option A or option B. Okay. So for question AI, we need to find the total amount Daniela would receive if she chooses the option A for right. So option A is that each payment is $4,200 for 3 years, right? And the payment is actually happening every month. So for question option A, we know that each payment is $4,200, and she's receiving it every month for, and that means there's 12 months per year, and she's receiving it for 3 years. So it means she will end up with this much of money. However, since we need to present our final answers in specific, the amount is this at the end. Okay. Then when she chooses the option B, we know that the first payment is $1,500, and each month which follows the payment is 40% more than the previous month, right? So for this question, we need to use the sum of the geometric sequence formula. Means we have to use the formula Sn equals U1 times R to the power of n minus 1 over R minus 1. Okay, since this person gains 4% more than the previous month, we know that the R value is equal to 1.04. So we can set the equation as S36. We're getting payment 36 times, right? 36 equals to U1 is 1,500, the first payment, times 1.04 to the power of 36 minus 1 over 1.04 minus 1. So when you do this, when you use your GDC, you get the amount of the 1163974707, and since we need to present our answers with the 2 decimal places, the final answer will be this. Okay, then let's do next question. So before that, we have actually new information, right? So this person received the inheritance, and then Sorin invested his inheritance in an account that pays a nominal annual interest rate of 5% per annum, compounded monthly. The interest is added on the last day of each month. So question B, we need to write down an expression for the value of the Sorin's investment after n years. So it says the nominal annual interest rate, right? So that means this is a compound interest question. Okay, so this question is from your topic or the chapter 1.4 of your curriculum. Okay, so from this section, we know that to calculate the compound interest, we have to use the formula FE equals PB times 1 plus r over 100k to power of k times n. Okay, so r is the interest, of course, and k, it refers to the number of the compounding periods per year. Okay, and n means number of the years. So for the case here, for question B, since we need to calculate the Soren's investment after n years, what you can do is we can start with what he has first, and then we do 1 plus the interest 5 over 100. Number of the compounding period per year is 12, and to the power of 12 times n. Then we have another information here. So we have Daniela now, who chooses the option B and received her first payment on 1st of January 2023, and Soren invested his inheritance on the same day. So question CI, we need to find the total value of the Daniela's winnings and Soren's investment on the last day of the 6 months. And CII, we need to find the minimum number of the complete months before the total value of Daniela's winnings and Soren's investment is at least this much. Okay, so for CI, we first have to calculate the Daniela's winning, right? So from the previous question, we know that the Daniela's winning can be calculated using the sum of the geometric sequence formula, right? So Daniela's winning is same as times 1.04 to the power of 6 minus 1 over 1.04 minus 1. So I'm using the n value equals 6 because we are just compounding for 6 months, right? Then we get the value of 9,949.46. Then for II, I'm using the previous question's formula, which is this to calculate the Soren's investment. But since we are compounding it for only for 6 months, we have to do 6, right? Then we get about 16,041.89 as the Soren's winning, or the Soren's investment. Then the total value is same as 9949.6 plus 169. So we get about this much of money at the end. Okay. Then question. Also, don't forget that for CI, we have to leave our final answer in 2 decimal places, right? Then for CII, we need to find the minimum number of the complete months before the total value of the Daniela's winnings and the Soren's investment is at least this much of money, right? So means II, when we add their winnings, but the month is unknown, so we can write our equation just like this. And it's greater than or equal to 20, right? So we need to solve for the n. So solving like this is almost it's like so complicated for your So solving inequalities in the form like this is very complicated. So the best way of solving this question is setting this or treating these equations using equal sign instead of the inequality. So you can set them equal to each other first. After that, on your GDC, using GDC, you can plug in the first part of equation as your y1 and this value as your y2 value and find the intercept between these two. Okay, then when you find the intercept, you will get the x value approximately equals to 28.44, and this is actually your months. So it means after 28.44 months, your value will be bigger than the value that was given. Okay, so since there's no such thing as 28.44 months, your months has to be 29, more than 29, to have a total values greater than $257,000. Okay. Okay, so let's try to the last question. So at the end of the 3 years, Daniela invested again for further 6 years in a second account that pays a nominal interest rate of R% per annum compounded quarterly. Means it's getting paid 4 times, right? The K is equal to 4. For question D, we need to find the value of the R if this investment grows to 41,000 after 6 years. So since this is like talking about the nominal interest, we have to use the compound interest formula. So we can do future value equals to present value times 1 plus R over 100 times K to the power of K times N, right? So future value is 41,000. Present value is 30,000. And we know that R is the unknown one and it is the value that we need to find. And K is 4 and the power is 4 times 6. So we can simplify this equation to this format. Then we can further simplify this, right? So it's 41,000 over 3,000 equals to 1 plus R over 400 to the power of 24. Okay, so now we need to solve this equation, right? The best way of doing this question on the paper 2 is using GDC again. So we can substitute this into your GDC as a first equation and substitute this as your second equation. Means we can do 41,000 divided by 30,000, and for y2 we can do 1 plus x divided by 400 to the power of 24, and we can graph it. Then you can see that there's an intersection here, right? Then using second car on your GDC, we can calculate the intersection of these two graphs. Then we can calculate that the x value is equal to 5.24027, which is equals to the R value, right? So we can say that the interest is approximately 5.24.